Hello everyone, myself Dr. Ansari Farzana, Chemistry Department, J.A.T.rts Science and Commerce College, Malegaon. Welcome all of you. Today we will continue about the instrumental parameters or the parameters used for instrumental analysis, scale of operation. To narrow the choice of method is to consider a scale on which analysis must conduct. Amount of sample available for analysis, concentration of analyte in it, and amount of analyte needed to get signal means, suppose for the colorimetric analysis, if we needed minimum one analyte to form color, and if it is less than color will not form, and we will have to take more sample for disintegration and solution formation. See here, this is a simple graphical representation. We should discuss later on this graphical representation. The scale of operation are shown on x-axis sample size, and on y-axis concentration in weight percent is given. If we divide analyte in different group as major analyte, that means sample contain more than 1% of analyte in 100 gram sample, minor analyte, trace analyte, and ultra trace analyte, and meso, micro, and ultra micro analyte size of analysis. That means if concentration of analyte is higher than sample size taken for analysis is a small, and if analyte concentration in sample is stressed, then amount of sample taken for analysis is macro quantity. For example, if analyte in sample is meso or macro, then analysis weight may be more than 0.1 gram. Diagonal line provide an easy way to define their limitation. For example, detectable analyte require 100 milligram. From the figure, it is suggested that this amount best to define the information on limitations. For example, detectable analyte require 100 milligram. From figure, it suggests that this amount best suitable for macro sample and the major analyte. Using this, we requires to take 100 gram of the sample, but it is complicated. Suitable to micro sample to major analyte. Using, we require to take 100 gram of the sample, but it is complicated in analysis. In such cases, minimum amount of analyte can decreases by improving the limitation associated with major signal. An analytical method has lowest and highest detection limit. We select lower limit to detection, and as per that reduce the sample taken for analysis. Also, upper concentration level is important because it determines how sample with high concentration of analyte must be treated before analysis. In this way, by using previous figure, the amount of sample required for analysis may determine equipment, time, and cost. Analytical method can be compared in terms of equipment need, time required for analysis, and cost of analysis per sample. Method which are dependent on instrumentation are instrument intensive method. They require significant training for operator. The time required for analysis of a single sample is fairly same for method to method. This is because much of time is spent on solution preparation and on equipment. Once solution and equipment are ready, number of sample analyzed per hour vary little from method to method. The cost of analysis includes cost of equipment and reagent, cost of here analysis, etc. Generally, instrumental method require more cost per sample than other method. Making the final choice. In making the final solution of method, generally the most important criteria is accuracy, and the best method is one which is produce most accurate result. The sample properties also play important role in selecting the method. If the sample contains the complex matrix, then it requires the method which has excellent selectivity in order to eliminate the interferences. If sample contains trace or ultra trace amount of analyte, then the method which gives good result at the level must be selected. Developing the procedure. Once the method is selected, next important step in the analysis is to develop a procedure. While developing the procedure, following point must be considered: compensating for interferences, selection and calibration of equipment, standardization method, sampling, validation of method. Compensating of interferences. The main source of interferences are reagent and interference present in the sample. When interferences are absent, the total measured is the sum of signal due to analyte and signal due to the reagent. That means S means SA plus S real is equal to KNA and S real. KC and straight. The signal due to reagent is in equation 1 and 2 are the signal for reagent or method blank which does not contain sample but eliminate or interferences in the sample matrix is difficult. If interference is known, the contribution is added to the reagent blank and hence can be eliminated. Most interferences are not known, and their contribution is also not known. In such can signal due to interference added to the total measured signal is as in this equation. Equation these 3 and 4 can be solved for both analyte and the interferences. I independent value of S measure are obtained as S measure 1 and S measure 2. See here, equation 5 and 6 can be solved simultaneously to determine the concentration of real Ca and concentration of interference C1. General form of equation 3 and 4, sample containing in analyte and interference can be written as S measure is equal to Ka N Ca plus K1 N C1 and plus S reagent. Calibration and standardization. Calibration is the process to ensure that siomol measured by an instrument or equipment is correct. For example, weighing balances are calibrated using standard platinum iridium prototype kilogram. The experimental process to determine the relation between signal and amount of analyte is known as standardization. To standardize a method, the graph of measured signal for one or more standard versus the analyte concentration in this standard is plotted, which is known as calibration curve. The sample whose analysis is to be carried out is carefully collected so that it should be representative of material from which sampling is carried out. Error in the sampling can cause significant error in analysis. To avoid this, sampling should be representative and contamination of the sample during or after sampling should be avoided. Validation is the process of verifying that a procedure gives acceptable result. It is also confirmed that the procedure provides sufficient details so that different analysts get reproducible result using the same procedure. Protocol are the set of written guidelines giving detail of procedure which must be followed. A protocol also contains clear instruction regarding internal and external quality assurance and quality control. Procedure internal QA or OC contains this is a step taken to assure that analysis work carried out in given laboratory is accurate and precise. In external QA or QC, laboratory is carried out by external agency, for example, Environmental Protection Agency, contract laboratory program. See here, it is a schematic diagram of portion of the contract laboratory program. Thank you for watching.